more on positive and negative numbers. And again, I'll give you the warning for these very basic videos. If you really know all this stuff inside out, you don't need to watch the video. In this video, we're just going to talk about multiplying and dividing positive and negative numbers, and we're going to talk a little about absolute value. So first of all, the rules for multiplication and division of positive and negative numbers are considerably simpler than the rules for addition and subtraction. First of all, let's talk about the sign rules. So for multiplication, positive times positive has to be positive. Negative times negative, the two negatives cancel and we get a positive. But positive times negative gives us negative. So in other words, same sign gives us a positive product, different sign gives us a negative product. The rules for division are similar. Positive divided by positive is positive. Negative divided by negative is also positive. The negatives cancel. But if we do positive divided by negative or negative divided by positive, we get a negative. And so again, same signs lead to a positive quotient. Different signs lead to a negative quotient. So we can just put everything together and combine sign rules. If we multiply or divide numbers with the same sign, the results are positive. If we multiply or divide numbers with different signs, the result is negative. So that's a really big fundamental idea there. It's important to be very clear on that. So when we're multiplying positive and negative numbers, really the easiest thing to do is first think through the sign rule. Do I want to end up with a positive answer or a negative answer? You should always know that before doing any calculations. Then usually the easiest thing to do is treat both things as positive, just perform the multiplication as if everything were positive, and then add the appropriate sign at the end. So for example, negative 6 times negative 7, negative times negative, that's positive. So that's going to be the same as 6 times 7, and 6 times 7 is 42. So positive 42 is the answer. Negative 65 over 5, that's going to be negative. And of course, 65 divided by 5 goes into 65 13 times. And so this is just negative 13. In the last one, negative 30 divided by negative 12, well, negative divided by negative is going to be positive again. It's going to be the positive fraction, and then we can reduce that fraction to 5 halves. And we'll talk more about fractions in the next module. Another topic related to positive and negative signs is absolute value. Many folks need to update their understanding of this. The naive definition, kind of a middle school definition of absolute value, is it makes everything positive. And this is a little problematic because, yes, it is true that it keeps a positive number positive, it makes a negative number positive, but it's also true that the absolute value of 0 is 0. See, 0 is neither positive nor negative, so it doesn't make 0 positive, it leaves it as 0. And so that's actually an important distinction there. Here's a much better way to think about absolute value. Much more sophisticated definition, the absolute value of a number gives the distance of the number from the origin. In other words, gives the distance of that number from 0 on the number line. So first of all, this is totally consistent with our previous understanding. The point 6 is the distance of 6 from 0 on the number line. The point negative 14 is a distance of positive 14 from 0, because distance is always positive. And of course, 0 is at a distance of 0 from 0. This new understanding has important implications in algebra. And so we'll just be talking about some of the very basics of algebra here for a moment. For example, the absolute value of x is the distance of x from the origin. And again, distance is always positive, so whether we're at positive 50 or negative 50, we're at a distance of 50 from the origin. What if we want the distance from x equals plus 5? Well, of course, the classic operation for finding distance on the number line is subtraction. So we're going to subtract and then take the absolute value of the difference. X minus 5, the absolute value of x minus 5. And of course, this works with numbers, if we think about it, because if we plug in 7, 7 is a distance of 2. Take the absolute value of 7 minus 5, that's absolute value of 2, which is 2. If we go down to x equals 3, that's also a distance of 2 from 5. We plug in x equals 3, we get 3 minus 5, absolute value of negative 2 is, of course, 2. And so in either case, it works. We're getting the distance from 5 on the number line. Now suppose we want the distance from x equals negative 3. Well, the same pattern, we're going to subtract the absolute value of x minus negative 3. But here's the tricky part. When we subtract a negative, we get a positive. And this is what really can confuse people. Why are we adding when it's a negative? Well, really what's happening is we're subtracting a negative, and subtracting a negative winds up as addition. Now notice this formula also works perfectly well, because if I try a point, say, negative x equals negative 4, well, what's the distance from negative 3 to negative 4? Well, if we plug in negative 4 plus 3, we'll get the absolute value of negative 1, which is 1. And it is a distance of 1. That makes sense. But what happens if we put in positive 4? Well, then we get the absolute value of 4 plus 3, which is 7. Well, what's going on there? Think about the number line. Here is negative 3. Here's 0. Here is positive 4. Well, what's the distance between them? Well, from 4 down to 0 is 4. From 0 down to negative 3 is another 3. So there is, in fact, a distance of 7 between positive 4 and negative 3. And that's what the formula gives us. So the formula actually works. If you're having trouble making sense of why the formula works, try plugging in numbers and thinking about where they are in the number line, and that will help you understand. So now let's think about one more example of this. The distance of x from positive 2, again we subtract x minus 2, absolute value of x minus 2. But the distance of x from negative 2, we're going to subtract a negative 2, and the subtraction winds up with it looking like addition. And so again, this is anti-intuitive. People see the switch in sign. How come the positive and negative goes to a negative and positive? Sometimes it really confuses people. What's going on is we're performing subtraction. When you subtract a positive, you get x minus 2. When you subtract a negative, you get x plus 2. And again, plugging in numbers and thinking about numbers on the number line can be a good way to think about this. Here's an equation. Pause the video and see if you can solve for this equation. Find the values of x in this equation. Okay, so what we're saying is, whatever x is, it is a distance of 4 from the location 1 on the number line. And so we could just find 1 on the number line and then walk a distance of 4 in either direction. And so if we walk to the right, we get to x equals 5. If we walk to the left, we get to x equals negative 3. So those are the solutions. The solutions are x equals negative 3 or x equals 5. Here's a practice problem. Pause the video, think about this, and then we'll talk about this. Okay. Now this is a question where you might be tempted to do a lot of calculations, and you don't actually have to do a lot of calculations. Let's think about this. We have 37 here. And the two solutions of this equation are a distance of 25 from 37. So we're going to go up to here. This is some distance of 25. We don't even care about that location. The other is a distance of 25 down here. We don't care about that location. All we know is that this is x1 and this is x2. Well, what's the d is the distance between x1 and x2. Well, that is just 25 plus 25, which is 50. And so d equals 50. In summary, when we multiply or divide like signs, the result is positive. When we multiply or divide unlike signs, the result is negative. Absolute value is the distance from 0.